So we're going to try to do that in 45 minutes. So it's from 0 to 60. All right, so first of all, what the hell is the web? Like I said, start from 0. The World Wide Web is basically the function through which computers share information between each other. It's a big system of HTML pages and resources that are from all across the globe. Now, typically, the traffic will be seen on either port 80 or port 8080 or HTTPS, which is 443 or 8443. But these can be substituted for alternative ports, but that's slightly more advanced stuff. And how do you get to this information? There is a browser for every day of the week, every week of the month, and there are still new browsers coming out. But the three big ones you need to know about are Safari, Chrome, and Internet Explorer, much to all of our chagrins, which are the three main market share browsers in the market today. And what's that? Oh, really? Oh, all right. I apologize. I did forget to mention Firefox, which is the second up there. But there are also other smaller ones like Opera or Opera or whatever else. So when I'm saying HTML, some people may not know what that means. So just to clarify, HTML is a standardization that basically unites the display principles across all the web pages for the internet. And HTTP is basically how requests are served. Now, there are a couple ways to see the requests that are being transferred from your browser to other sites. One of my favorites is Burp Suite, which is a man-in-the-middle proxy that allows you to actually intercept the request and see what exactly every request you're making is sending out. It's the most effective way to actually view requests. There are others. You can Wireshark if you want to. You can leave your friends behind, but you don't proxy, you ain't no friend of mine. So for the presentation, anything that I show you, we'll be using Burp Suite. Now, Burp Suite is a very powerful tool if used correctly. We're not going to go in-depth into how to use it or anything like that, but just for bringing you up to speed, essentially what you do is you set your local host on port 8080 as your outbound browser proxy, and you're able to actually intercept the requests as they're being sent, and you can see it in real time. Now, you're able to both set your listener on different ports. So you're not bound to just 8080. You can do 9090 or any number of the other ungodly number of ports. And you can also intercept responses, which is really useful if you have a specific response which you're trying to escape, and you're wondering exactly what it would take to execute your particular attack. You can modify the request in Burp and see it before you actually exploit. So HTTP request is built around a couple different things. There's the host, which is the server which you're issuing the request to. This is the server that will deal with any traffic that you send and will send the responses back from. There's the user agent, which is what your browser passes to the server to identify you and to tell your server exactly what it is that the request is coming from. Now, there's also cookies, which are typically server-defined, although in some extreme edge cases you can set your own cookies. And there's also connection state. But don't make the mistake of thinking that these are the only request headers. There are sent requests per RFC 2616, I believe. There's like 47 different request headers that you can send out. And all of these have a specific use, both in maintaining state and as server interaction, as well as modifying it. Now, there are a couple different parts to a URL. Essentially, you have the protocol, which you can change to the FTP, TFTP, whatever you want, as well as your subdomain, domain name, the TLD, as well as any parameters which are actually being passed to the server. And these are, the parameters are typically what you provide to the specific resource in order to modify the result of the page. Now, not only can these be passed via GET requests, but oftentimes in post requests, which we'll get into later, they are used more intrinsically in the resources to modify content. Now, when I'm talking about cookies, I'm not talking about chocolate chip or white chocolate chip macadamia, even though, you know, you would expect it. Cookies are basically a clever hack around the fact that HTTP is essentially stateless. It's a stateless protocol, meaning there's no built-in functionality for me to say, okay, I've logged in, where's my session? There's none of that. So developers have had to hack on cookies, which are at best an imperfect means of establishing identity. And typically they're set upon login, although several identifying cookies, tracker information, stuff like that, will often be set upon initial visit of the web page. And when I say it's an imperfect solution, that's exactly what I mean, because this is where you'll find a lot of problems, such as insufficient authentication, authorization, all kinds of things which are less than desirable in an application. Now, responses, HTML responses are the way that the server provides the web page to you. So if you just sent out a request to a web page and said, okay, modify it, but don't show me anything, it would modify it on the back end, but you wouldn't see any resulting web page. There would be no output from the server. Now, there are a couple different content types which all have a different use, both in rendering normal content on the application, as well as potential exploit scenarios. So, for example, if you're sourcing a audio file, there are a lot of times where potentially you can modify the source of the file to pull in something completely different. And I've seen it where financial companies are sourcing in, quote unquote, sound bites for their marketing pages, but which are, you can actually source in competing sound bites. So instead of saying, buy our stock, you can say, buy our competitor's stock. Lots of interesting little things. But now that some of the more basic stuff is out of the way, let's get to kind of the meat and potatoes, so to speak. Just full disclosure, there is lots of discussion of ownage and cross-site scripting and SQL injection, yeah. And if that triggers PTSD in anyone, I would recommend leaving. Now, who the hell is your threat? It's this guy. It's everyone in here, basically. Anyone who has a computer. Now, first and foremost, the attacker that a lot of people think about, he doesn't exist. He's not this omnipresent being who is able to SQL food into every one of your servers by, going to hackerhyper.net. It doesn't work that way. But what he is everyone in this room. They're curious. They're people who want to dig as hard as they can to find one little piece of information which could potentially ruin a company. And typically they're better than you. Not through the fault of the company itself, but because of the wall fort scenario. You can only build a fort so high, and there will always be a way in. And there's always going to be someone to look at that server until the walls come falling down. And of course, they're not fueled by Rondo, even though it is a real thing. So when you're attacking a site, what do you want? Now, a lot of people talk about, hacking sites and, oh, I'm going to own you or whatever, but typically you're looking for the most volatile information that you can get. Usernames, passwords, financial data, things that you're not supposed to see. A big one is source code, and that's what a lot of the quote-unquote APT is focusing on. I hate using that word, by the way, but that's the industry-recognized term for foreign attackers. So if you see foreign companies trying to attack domestic sites, they're looking for source code, they're looking for intellectual property, which can be used to remonetize ideas at a cheaper rate. So basically what you're looking to do is get as much information as quick as possible with the least possible overhead. Now, there are a couple ways to get any piece of information you want, and these are, what I'm going to talk about is just a couple. There are hundreds of exploits which are possible to be chained together to form entirely new concepts, which it's very possible that haven't even been categorized yet. But the top resources that you need to go to if you are looking for attack types would be the Web Appsec Consortium, or WASP, or the Open Web App Security Project. Those are the two big ones right now in the industry that you'll need to reference. One of my favorites is a attack called insufficient authentication, which is the concept behind it is a normal login process is you go to the login page, you enter your credentials, and it checks them, and then you are authorized to get into the application. Authentication bypass does exactly what it says. It completely goes around the typical authentication procedure. So essentially what you're looking for when you're looking to exploit something like this, in a request, if you see anything that says admin equals or admin anything, play with it. That, curiosity is your number one attack friend in this in attacking things. Anything with user ID, admin equals true. A lot of times, corporations will take shortcuts around expected procedures. So instead of properly checking admin's authorization versus a normal user, they'll just drop in admin equals false on every user, which you could then modify to admin equals true. And in the application itself, it sees admin equals true, and automatically, as a regular user, you're able to add new users, you're able to add new admins, you're able to delete content, you're able to see sections of the site that only admins should see. And typically, a lot of times, user IDs will be sequential. So you'll have user ID equals 1. Now, if you're able to iterate through numbers, a lot of times the further down you go, the closer to an administrative level you get. So applications are typically built from the bottom up instead of vice versa. So if you go down to 0, a lot of times you will find an administrative user. And they can typically be abused to get administrative functionality, but you can also get eyes-only information. Now, this is the scenario I was telling you about. Basically, you're looking for anything with file ID or item ID, things like that, which could be potentially sensitive. And with each application that you're testing, you have to be specific to that one. There's no one answer to how you can find a vulnerability. It's all in context. You have to view any attack in context. So be sure to see exactly where the administrative functionality is coming from. Insufficient authorization is basically, typically you do an auth check as Tom to access Tom's data. Now, in this case, Tom is doing an auth check, but he's actually accessing Mary's data instead. Now, this is really bad because Tom shouldn't be able to see Mary's data. Not only because it's Mary's data and not Tom's, but because there could be potentially sensitive information there. And insufficient auth can be as simple as iterating through IDs, or it could be extremely complicated, such as doing cookie substitution inside of a request, or even modifying your own cookies in order to gain administrative privileges through insufficient authorization, which is likewise really bad. One example I have here is of a bounce dome packaging management app, which is it's really interesting because if you're able to go in and actually change the bank ID at the end of the string from, let's say, from a 1 to a 9, you're able to actually access full information for a completely different bank account from your own, which, in this case, you're able to actually see immediately. You're able to see account information, you're able to see, you're able to make transfers, do whatever you want inside of that person's bank account simply by changing one number, which, this actually happened on a big bank, what was it, a year and a half ago, 2 years? A large national bank was hacked by a simple digit rotation on the end of their string, which allowed for approximately, I think, $6 million to be taken from their accounts. And it took zero effort. It took one person looking at a string and a URL and saying, something's not right there. So just a couple of trips, a couple of tips and tricks. User IDs a lot of times are sequential. Just go 1, 2, 3, 4, et cetera, et cetera. And a lot of times the administrative accounts will reveal sensitive information. A lot of times they'll have authorization checks in place, but if you try and access sensitive files directly, as opposed to going through typical expected paths, you can access those sensitive files without undergoing the actual check itself. Now, session hijacking is a fun concept because a lot of times the cookies that we were talking about earlier, which are the only thing that maintains state in a application. If you transfer those over insecure methods, such as a GET request or being passed in the parameters of a URL, anyone between yourself and the server who's possibly running an the attack is able to see those cookies. Now, that's bad because if you're able to copy those cookies and supply them in your own request, you can essentially become that user with only potentially a wire shard of the traffic that's coming through your network. And this is without knowing your username or password. If you can copy a cookie, a lot of times you're able to go in and change passwords. You're able to even in some cases change usernames. And there's a lot of different cookie IDs to look out for, specifically JSession ID and ASPX off. Those are both often passed in the URL, both through insecure coding and insecure development. But that's one of my favorites. Now to everyone's favorite. He said mocking. Cross-site scripting is everywhere. It's everywhere, it's everywhere, it's everywhere, it's everywhere, it's everywhere. Now, cross-site scripting basically allows for an attacker to supply their own meta characters or their own data to directly to an HTML page and execute their own JavaScript on a attacker on a third-party domain. Now, this is obviously bad because it can lead to, it can lead to cookie disclosure, which could lead to a session hijacking attack, or it can, you can redirect people, whatever you want to do. You can also force people to download malware simply by a single request. And it's typically achieved by servers that are allowing unsanitized data to be stored on their server, which is something you should never do. You should always output and code anything that you take from your users, because I don't care how well intended they are, they're going to do something stupid. And there are three typical types of XSS. There's DOM-based, which is inside of the distributed object model of a web app or browser. There's non-persistent, which is, for example, on the search page. If you search and immediately a XSS window pops up. Typically, those kind of attacks require a bit of social engineering or phishing in order to actually render any results. But the most dangerous is persistent XSS, which is obviously stored on a web application for anyone to use. Just a quick example is essentially the things that you want to look for would be any login screen, absolutely any login screen, which is reflecting input, log files, error messages. A lot of times admins will store information under the guise of basically keeping a record of anyone's transactions on the site. A lot of times in the background, they're storing your requests without properly encoding them. So, a lot of times, even if you are not getting an immediate result with a request, if you set it up to send your cookie or send any captured cookies to a remote server, regardless of state, a lot of times, 2 or 3 months down the road, you might get a surprise in your inbox because admins don't check logs every day, and even if they did, there's no guarantee that you'll hit the appropriate one. Now, typically what you're doing is you're looking for any of these characters which are reflected unencoded in a HTML page. Single quotes, double quotes, etc. Things that allow you to escape a given context that your input is landing in, and then create your own. Now, a lot of times your input will be output encoded, like I was talking about earlier. And there are different encodings that you as an attacker can use to actually attempt to bypass that output encoding. So one method would be to just URL encode, because a lot of applications will HTML encode any entities that are provided unencoded to the server. But if you provide a level of abstraction between the initial encoding and the next one, it's kind of an iterative process. So maybe they only do one iteration of output encoding. So essentially, the server is attacking itself on your instructions. Hex encoding is a much rarer use case. Occasionally, there will be a web app firewall in place which will allow you to provide very unique encoding methods which will render correctly when executed. And just as a use case, here's a sample, a little bit of code. And typically, your code is reflected inside of one spot inside of one page. In this case, your input is being reflected inside of a string tag, which is good, but you have to escape that because there's already declared action inside of the tag. So typically, what I'll do in this case is escape the JavaScript landing that you're inside of in order to declare your own tag, your own JavaScript statement in order to execute your malicious code, which could be anything from just saying, okay, here's your cookies, to all right, you're going to go to this page now and download malware. Now, one thing that a lot of people don't know about when they're starting out is injecting iframes into an application, which is a lot of fun. Just from a hey, look what I can do point of view. It's a lot of fun to basically take a competitor's webpage and inject an iframe, which just pops up a massive display of your site and just overlap everything on their page. But iframes basically allow you to source in a browser inside of a browser. So you're pulling in an external page inside of their page. It's just a lot of fun. And it's also really useful for possible regex rules that they have on their application itself. All right, SQL injection. All right, SQL injection. This is not something that you can sneeze and you automatically get everyone's docs. It doesn't happen. It's a structured query language. Just because you have a tool which fuzzes every possible iteration of every single character does not mean that you know how to attack SQL. And it's pronounced SQL, it's not squeal. If I hear that one more time, we got a freak. But typically, SQL is used for storing relational data for transactional databases, or in some cases files, and in other cases, I've actually seen it store server instructions for the server to call from the database in order for the server to call from the database. It just so many levels of fun. But another SQL joke. A SQL query walks into a bar and sees two tables. Great! Oh Lord, I need a drink right now. All right. There are a couple different SQL databases. The big ones right now are MySQL, Oracle, and MS SQL. There are definitely other ones, don't get me wrong, but those are the two big ones. As far as exploiting those, I'm sure all of y'all have seen that picture of the car, but typically what the license plate scanners do is they store the data in a database, and then it's called back. What this person did was basically just went in and dropped every table in their county's license plate scanner database, so they didn't have to pay any parking tickets at all. So, SQL queries are typically passed to a server inside of statements. A lot of times, what companies will do is parameterize their requests so that SQL injection isn't a problem. That's not done as often as I'd like. Typically, what you're looking for is single ticks, bars, whatever you can get in. A lot of times you'll get SQL error messages. Now, a lot of times SQL is used to call private information from inside the network itself. Now, SQL injection you can use for any varied number of purposes, such as defacement of sites, of course, malware, whatever you want to do, you can pretty much do it. Sorry, I'm going to have to jump along here. So the typical workflow for a SQL injection vulnerability, especially error-based, you're making a request that contains meta characters, which are typically contain a single tick or something like that. You're looking for an error message. A lot of times, if you provide an errant single tick, the application will error out, saying that the SQL statement was in error, obviously, and it won't render correctly. So you'll get an error message, and you can correct your syntax where it's correct, and you're calling the information that you want to call, and you can correct it iteratively as you go until you get what you need. There's also blind SQL, which is a little bit more difficult to pull off, even for trained attackers. What you're basically doing is just blind firing meta characters or any SQL statements that you want to try and call your main, and unless you see a change in the rendered content of the page, there's really no way to know if it's working or not. But blind SQL can be among the most effective attacks because even if you don't know what's happening, you might be destroying someone's database on the back end. Now, the last attack I think I'm going to talk about is cross-site request forgery. And I'm sorry, there is absolutely no way to make Caesar funny. I've tried. I've been thinking for 2.5 weeks of some video on. Nothing came out. Typically, what Caesar is it's a way of forcing someone to make a request they wouldn't normally make, and without their knowledge. Typically, applications are built around the mindset that if you make this request, you meant to make it. There's no human verification. There's no CAPTCHAs or anything being done to ensure that the request came from a human. An attacker is able to exploit this by forcing a victim to make requests which they didn't mean to make. Typically, sensitive information that you're looking for, CSRF, is password changes, account transfers, anything that could be state changing in an application, you're looking to see if it's vulnerable. And a typical attack scenario is something along these lines. And it basically discovers that sensitive information is being transferred over a GET request. She modifies the link to say change the amount of money that's being transferred from $100 to $100,000. And then she notices that in the account field, it's her username. So she creates a little image on her site, which Maria happens to visit very frequently. And when it's loaded up by Maria, it automatically transfers $100,000 to Annie or to Bob's account. And all this is done without Maria's knowledge. So Maria's an overachiever. She has hundreds of thousands of dollars, but Annie's rich from 10 seconds of work. And there are banks that are that oblivious. And guys, there was a time when those kind of vulnerabilities were completely out of reach from normal people, but it's not the case anymore. And with zero training, you're able to do things like this. And this is just the things that we discussed today. Insufficient authentication for one, insufficient authorization for two, session hijacking for three, and so many of the other things that we were talking about. You're able to exploit. But before I finish, I just want to give you all two quick little things for if you're ever interacting with a web app firewall. There are a couple of quick things that you should know. Like I was telling you earlier, double encoding a lot of times will bypass their checks by web app firewalls, and you can actually get in and bypass it. Also, NOP sleds. If you remember from back in the day, NOP sleds were used to execute data from within code. NOP sleds are still relevant. You can still use them. And a lot of times with WAFs, if you provide like 10 NOPs in a row, there are WAFs that are being used today that will completely fry and not analyze any of the traffic that you're sending it for 15 minutes simply by sending NOPs. And that means that you can get any traffic that you want through that server without any problems, without any logging, all kinds of fun stuff. And basically gives you a get out of jail free card. So, guys, thank you for sticking with me. I'm sorry I was late.